We're going to look at this scenario, which is different from how we usually press inverse norm, just like how we have mentioned about it in the previous video. We are looking at one where this is an inequality instead of an equal to. If it is an equal to, we will actually be able to make use of the inverse norm feature in our calculator directly. But because it is not, we will still be making use of the calculator, but at the same time, we will have to do an extra improvisation and deduction. So the first thing that we will do is to simulate something that is similar to this by trying out for a probability of x to be bigger than another number, let's say k. I'll replace this by equal 0.25. And we're going to press into our calculator to try to find k because we have a situation which we can definitely make use of the inverse norm directly from our calculator. So let's try on our calculator. We are going to go for second vast inverse norm. And here is 0.25, the area. The mean is 2.5 for this x. The standard deviation is square root of 0.78. And we're looking at the area that is to the right of k. So the tail here is going to be right. Let's paste this. And if I were to paste and enter, we are going to be getting k here to be equal to 3.10. So this is for k. We are trying to find out about a. So what we are going to do is we are going to try to first visualize this on a bell curve. The bell curve is going to be meant for x, and we know that the middle here is 2.5. So what we are seeing here is that the area to the right of 3.10 is equal to 0.25. So for example here, let's say this is 3.10. So this region here on our bell curve will have an area of 0.25. Now let's come back to this that is here. We are going to make use of our bell curve and this region here which has an area of 0.25 to deduce information about A. So if I were to have that being represented here, we can see that the area to the right of A, this number A, must be an area that is less than 0.25. So physically, A should be a number that is to the right of 3.10 in order for the area to its right, this area here, to be an area that is less than 0.25. So with our deduction, pressing the calculator with our deduction, we can see that A has to be a number that is bigger than 3.10 in order for the area to the right of it to be an area that is less than 0.25. We can also try to take a look at another similar scenario, which is when the area to the right of A is an area that is bigger than 0.25. So for a situation that is like this, we will go through the same process. We will try to do a simulation of this again using our calculator, replacing A by K, replacing this inequality by an equal to. Pressing into our calculator, we get K to be equal to 3.10. Then we will try to represent this on the bell curve. Here is going to be X. Here is 2.5. The area to the right of 3.10 is an area that is equal to 0.25. This is directly from our calculator, but in order for us to find out about A, we have to put in our own effort to do an extra deduction. So the area to the right of this number A is an area that is bigger than 0.25. This is equal to 0.25. So if an area that is to the right of A is bigger than 0.25, A has to be somewhere to the left of 3.10 in order for the area to its right, which is here, to be an area that is going to be bigger than 0.25. So with our deduction, we know that A has to be a number that is less than 3.10. So A is less than 3.10.